enters the turbine housing, the turbine housing works as a vaneless nozzle, converting pressure energy available in the exhaust gas into high velocity gas. This gas expands over the turbine wheel blades, causing the turbine wheel to rotate. The turbine wheel speed increases with the increasing amount of exhaust gas entering the turbine housing. With fixed size of turbine housing, the turbine wheel speed will maximum when the quantity and temperature of the gas are maximum. The speed of the turbine and compressor wheels increase and decrease based on the quantity of the exhaust gas and its temperature entering the turbine housing. Waste-gated turbocharger. Waste-gated turbocharger has an additional mechanism called wastegate and actuator assembly. This mechanism will limit the maximum boost developed by the turbocharger. The actuator assembly has got a spring-loaded diaphragm and is mounted onto the compressor housing. A hose connects compressor housing with actuator to ensure that the pressure in the compressor and the actuator is same. In a normal working condition, the spring-loaded diaphragm keeps the wastegate flap in closed condition. When the air pressure in the compressor exceeds the diaphragm spring pressure, the spring gets compressed, diaphragm moves and opens the wastegate flap assembly fitted in the turbine housing assembly, thereby allowing some amount of the exhaust gases to bypass the turbine wheel and exiting through turbine housing outlet. The reduction in quantity of exhaust gases will result in decrease of turbine wheel speed. Consequently, pressure in the compressor housing will be reduced. Since the air pressure is less, the diaphragm moves back to its original position due to spring pressure, and the wastegate flap assembly also comes back to its original closed position. Thus, the maximum boost pressure developed is always limited to the set value determined by the engine manufacturer. Variable turbine geometry turbocharger. VTG turbocharger, as the name suggested, has got a separate mechanism inside the turbine housing. This enables the turbine housing to work line a smaller area housing, medium area housing, and larger area housing based on the engine demand. Since the area of the turbine housing can be varied, it is called a variable turbine geometry turbocharger. The turbine housing has got a set of vanes placed in the exhaust gas passage area above the turbine wheel. The exhaust gas entering the turbine housing has to pass through the vanes to reach turbine wheel. Initially, the actuator and vanes are partially closed. The actuator rod moves down and opens the vanes. Though there is higher amount of exhaust gases are entering the turbine housing, the turbine wheel speed is slow because of open vanes. The actuator rod moves up and closes the vanes. Turbine wheel speed increases. The actuator rod moves down and opens the vanes. Turbine wheel speed decreases. The actuator rod moves up and closes the vanes. Turbine wheel speed increases. All the vanes are connected to a ring, and this ring is connected to the actuator control rod. The actuator is connected to engine vacuum circuit. The electrical switch operates the vacuum flow to the actuator, and the switch is operated by engine ECU. We can see the actuator rod movement and the van ring movement from compressor side. Though the flow of exhaust gas and its temperature still determine the speed of the turbine wheel, based on the ECU demand, the actuator, with the help of vanes, closes or opens the exhaust gas passage in the turbine housing, leading to increase or decrease of exhaust gas pressure inside the turbine housing, thereby manipulating the turbine wheel speed independent of engine exhaust gas flow. Waist-gated turbocharger. Waist-gated turbo compressor housing with an